Good afternoon, dear students. How are you? I'm fine. So, previous class we discussed about the compounds of hydrogen. In compounds of hydrogen, what is the compound? We look at it. Water. So, in water, chemical properties we have completed up to the ionic compounds. Water dissolved in ionic compounds. Up to there, we completed. Today's class, we are going to discuss the last chemical property of water. Formation of coordinate bond are present in interstitial position of crystals. This is one of the chemical property of water. So the aqueous solution of hydrated crystal can produce the salt from that solution. Okay. So the salt which is present in aqueous solution or water in the hydrated salt, they can produce the coordinated bond between that compounds, between that elements which is present in that hydrated salt in water or aqueous solution of hydrated crystals. For example, Cr H2O 6 Cl3. In this example, cation which is present in that compound, cation which is cation, chromium is cation, which is present in that compound, it is bonded with the ligand. What is ligand? H2O. 6H2O is present or it is bonded with chromium. So chromium is bonded with H2O, 6H2O. They can form the bond between chromium and water. It is a coordinate bond. So all the water molecule or 6 water molecule which is present in this example is coordinate, it form the coordinate bond between chromium and water. So chlorine is anion, chromium cations, H2O ligands, and cations and ligand form coordinate bond. So if they form the coordinate bond between cation and ligands, that compound is known as coordinate compound. So there is another example for explaining the coordinate bond or the interstitial position of crystal or the interstitial position of the compound. For explaining the interstitial position of crystals, we are going to take the example, second example, BaCl2 2H2O. In this example, it contains 2 molecules of water. So these 2 molecules are present in the interstitial position. This barium is directly bonded with this 2 chlorine and they are bonded in the another 2 molecules of water are bonded with the barium in the interstitial position. That means not in the coordination bond, but they are bonded with that metal cation. It is a distant position and they are far away from the center of the metal or the metal cation. Next example, CuSO4 5H2O. This is one of the compound which is explaining the coordination bond. In this compound, from this 5 water molecule, 4 water molecules are directly bonded or it is coordinate with the metal cation. So the remaining water molecule or the 5th water molecule, it's not directly bonded or not in the coordination bond. So they can form outside the coordination. And also they can form the intermolecular hydrogen bond with another molecule. They are forming the intermolecular hydrogen bond with another molecule. That means the copper is bonding with the fifth water molecule in the outside coordination bond. So they can form the hydrogen bond, and they will the formation of the hydrogen bond is CuH2O 4 times, SO4 H2O. You can see the difference. 4 hydrogen water molecule are directly bonded with the metal cation, or they are in the interstitial position, and H2O, the remaining H2O from the 5H2O, it is in outside of the coordination. Okay, so the chemical properties of the compound of hydrogen is completed. Next topic from this unit is the important one, hard and soft water. This is one of the specified character of water, hard and soft water. Generally, we use water for daily uses in our home, for the domestic use like washing vessels and washing clothes, for bath, and for cleaning the house, or for cleaning some things. For this all kind of work, we used water, and you use the water with some detergent or some floor wash solution and soap, etc. In some kind of water, the soap, detergent and wash solution what we are used in for cleaning, they not give more froth. Okay, why? Because of the character of water, hard and soft water. Generally, hard and soft water, they are opposite character. Hard water, they can't give more froth for using the detergent and soap. Soft water, they what we are using in a daily life, most of the water are soft water, and they can produce more bubbles and more froth of soap, detergent, and what are the liquids we use for the cleaning purpose or any kind of purpose. So hard water means they contain high amount of mineral ions. Okay, that means what? They contain some cations which is soluble in that particular water. So the soluble salt of cation in water is generally known as hard water or hard character of water. So the high amount of mineral ions. What are the mineral ions which is dissolved in the water? So the mineral ions like magnesium, calcium, maybe iron, aluminium and manganese, and sometimes lead. So the soluble water in soluble ions in the water is known as hard water. So the definition of hard water is, the most common ions which is found in the hard water are the soluble metal cations such as magnesium and calcium, iron, aluminium and manganese, which is dissolved in the water. Okay. So presence of these ions, the metal cations like magnesium and calcium, they can form bicarbonate and chloride, then sulfate of that particular metal cation. For example, magnesium bicarbonate and calcium bicarbonate, calcium chloride, magnesium chloride, magnesium sulfate, calcium sulfate. Okay, they can form the compound like this, and this character, this bicarbonate or the sulfate or chloride of this dissolved cations like magnesium and calcium is make this water hard. When the hard water is boiled, the carbonate of the magnesium carbonate or the calcium carbonate is deposited at a precipitate. So they can easily precipitate out the hard character of water is precipitating out as like in the form of magnesium carbonate and calcium carbonate. So hard water means presence of metal cations, presence of metal cation dissolved in water, and they can form salt like bicarbonate, sulfate, chloride. This formation of the salt make the water hard. They can precipitate out by heating. This is hard water. Then next, soft water. Water is free from the soluble salts like calcium and magnesium is called soft water. Free from soluble salt like calcium and magnesium. Hardness of water is separated out, classified by heating. So it is separated out by heating. So they can, by heating you can precipitate that compounds. The next one is classification of hardness of water. There are two types of classification. First one, temporary hardness. Second one, permanent hardness. So we classify the hardness of water into two types, temporary hardness and its removal we are going to see in this session, and permanent hardness of water and their removal of the hardness. Temporary hardness is explained or why we call this as a temporary hardness, because of presence of magnesium bicarbonate and calcium bicarbonate. So temporary hardness means presence of magnesium bicarbonate and calcium bicarbonate. And why this permanent hardness called, why we classified this as permanent hardness? Because of the presence of salt like presence of salt, magnesium, calcium, magnesium chloride or magnesium sulfate, okay, and calcium chloride and calcium sulfate. So the presence of magnesium chloride and magnesium sulfate, calcium chloride and calcium sulfate is known as permanent hardness of water, permanent hard character of water, and the presence of magnesium bicarbonate, calcium bicarbonate in the water, the salt which is present, magnesium bicarbonate and calcium bicarbonate in water, that water is known as temporary hardness of that water. Okay. Temporary hardness of water we can easily remove by boiling that hard water and getting that precipitate out by the filtration, that we already know in the type of hard and soft water. We already know that it is precipitate out by heating. So if you heated boiled out the temporary hard water, then you can get the precipitate, and the precipitate is filtered out from the water. You will get the soft water, or without hardness you will get the water. So hardness is removed by heating in the temporary hard water. In temporary hardness, what are the salts are present in the water? Magnesium bicarbonate and calcium bicarbonate. So write magnesium bicarbonate and calcium bicarbonate. Calcium bicarbonate undergo heating, or it is undergo boiling. It is precipitated out calcium carbonate. So what is the formula of calcium carbonate? CaCO3, which is precipitated out by heating, and the remaining compounds H2O plus CO2. Okay. Calcium is combined with carbonate. You have two molecules, two carbonate and two hydrogen. So one carbonate is removed with the calcium carbonate, remaining one carbonate and one hydrogen is present in the side. Now this hydrogen, two hydrogen is present here, one carbonate and two hydrogen is present. Now this two hydrogen is combined with one oxygen from this carbonate and it forms H2O. Then the remaining from the CO3, one O is combined with the hydrogen, so the remaining two oxygen. So it forms CO2 as a byproduct, H2O as a byproduct. Two byproduct, and the major product calcium carbonate, it is precipitated out and you can filtrate that one. And then the hardness of the water is removed by this heating method. As like the calcium bicarbonate, magnesium bicarbonate also treating in the boiling reaction. So magnesium bicarbonate undergo boiling reaction. Then it is precipitated out as like the previous reaction, magnesium carbonate. So metal cation is combined with the carbonate salt. It forms magnesium carbonate as a major product, or it is precipitated out. And the remaining one are the byproduct of this reaction. Same, two hydrogen is combined with one oxygen from this carbonate and it form H2O is first byproduct, and the remaining CO2 is formed. CO2 is another byproduct. Treating this magnesium carbonate with water or hydrolyzing this magnesium carbonate, you will get magnesium hydroxide as a product. It is an insoluble one. So magnesium carbonate is hydrolyzed with water. Hydrolyze means adding water. Then the reaction, the product of the reaction is magnesium hydroxide plus CO2. It is insoluble and it is also a precipitate. So the resulting precipitate are filtrated out from the water. You can easily remove the hardness of the water. This is first method to remove the temporary hardness of water, and second method is Clark's method. Clark's method is a second method to remove the hardness of water from the temporary hard water. So in this Clark method, we treated the hard water, temporary hard water, into the calculated amount of lime, and it is removing here the carbonate and hydroxide of magnesium and calcium. That means magnesium carbonate and calcium carbonate, then magnesium hydroxide, calcium hydroxide. Okay. So what is the formula of lime? CaOH twice. This is lime. So the calculated amount of lime is treated with the hardness of water. That means what is the hardness of water? What is hardness of water? Calcium bicarbonate and magnesium bicarbonate in the temporary hardness. So here we can write calcium bicarbonate is treating with lime calcium hydroxide, and it's removed here calcium carbonate as a byproduct and water. 2 molecules of calcium carbonate. Here you see 2 molecules of carbonate is present in calcium carbonate. This calcium is combined with the 2 molecules of carbonate and it is separated out calcium carbonate. The remaining hydrogen and OH twice, totally 4 hydrogen and 2 oxygen, they combined here as water molecule. So 2 molecules of calcium is combined with the 2 molecules of carbonate. It forms calcium carbonate 2 molecules. As like the calcium carbonate, calcium bicarbonate, magnesium bicarbonate also undergo the removal of hardness by Clark's method by treating this magnesium bicarbonate with lime calcium hydroxide 2 molecules. Treating this both, it forms calcium carbonate 2 molecules, magnesium hydroxide and 2 molecules of water. See this reaction, 2 molecules of calcium is present here and it is combined with 2 molecules of carbonate from the magnesium bicarbonate. Both are combined and they form calcium carbonate 2 molecules. 2 calcium and 2 carbonate. 2 molecules of calcium carbonate. And this magnesium is combined with OH twice. Okay. So this OH twice. Totally 4 are present. So 2 is combined with the magnesium. It forms MgOH twice. Remaining OH and this 2 hydrogen combined together and they form 2H2O is the byproduct. So from the Clark's method to treating this temporary hardness of the water with lime and it is separate out the hydroxide of magnesium and carbonate of calcium is remove the hardness of water from the temporary hard water. Separating out the hardness from the temporary hard water is completed. Next, we are going to see the permanent hardness of water, how it's removed. You already know that the salt which is present in the permanent hardness are magnesium, magnesium chloride, magnesium sulfate, calcium chloride and calcium sulfate. So removing this calcium chloride, calcium sulfate, magnesium chloride and magnesium sulfide, treating this hard water, permanent hard water with the washing soda. Because of treating this permanent hard water with the washing soda, it can form the carbonate form of the given metal compound. So the removal of hardness from the permanent hard water, we treat here metal. M is denote here, this is metal. Metal means what are the metals are present in the metal permanent hardness? Magnesium and calcium. This two metal cation. You can denote here magnesium and calcium as M. Magnesium chloride or calcium chloride is treating with washing soda. What is the formula of washing soda? Na2CO3. Now both are reacted together and they form the product are magnesium carbonate or calcium carbonate. The byproduct is sodium chloride. See this reaction. Metal cation is combined with the carbonate and they form metal carbonate. That means magnesium carbonate or the calcium carbonate. They have the chance in magnesium and calcium carbonate. And the remaining one, this chlorine is combined with the sodium and they form two molecules of sodium chloride. So the chlorine form of the metal cation is removing, and the next one, sulfate of magnesium and calcium. That means magnesium sulfate and calcium sulfate again is treated with washing soda Na2CO3. Now the result of this reaction is this is also the product of this reaction, also the metal carbonate. It may be the magnesium carbonate or calcium carbonate. And the byproduct of this reaction, Na2SO4. Na2SO4. Now the hardness of the permanent hardness of hard water is removed by adding this with Na2CO3, that means washing soda. This is one type, and we use the another method to remove the permanent hardness from this permanent hard water by adding this ion exchange method, or using this ion exchange method with the zeolite or ion exchange bed zeolites. In this method, we used here the ion exchanging or the metal removing ions used here, zeolites, or using zeolite beds to remove the hardness, or column containing ion exchange resin. General formula of zeolites are here we used here one of the zeolite is hydrated sodium aluminosilicate. The formula of hydrated sodium aluminosilicates NaOAl2O3 X SiO2 Y H2O. Here the range of X is 2 to 10 and the range of Y is 2 to 6. So you can use here 2 moles to 10 moles of SiO2 and 2 moles to 6 moles of H2O in the zeolites. Zeolites are generally porous structure, they contain porous structure, and the sodium ions are loosely bounded, loosely held with the compound. So this sodium is loosely held with the compound. So using this sodium to remove the metal cation from the permanent hard water. So the example of this reaction is Na2Z. Z means zeolite. Here we mentioned here Na2Z. Why? Because this sodium is loosely bounded. So it is easily removing. We can easily remove this loosely bounded sodium with a zeolite. So we mentioned here Na2 is a separate one. Z is denote here is a zeolite, the remaining compound in the zeolite. So sodium is using here to remove the metal of the water. So the reaction of this zeolite is Na2Z metal cation, and this zeolite is removed with this metal cation. So this metal cation is bonded with the zeolite and the loosely bounded sodium is removed out. So this is the whole reaction to removing the metal of permanent hard water. When exhausted, the material can degenerate, and treating this with the aqueous sodium chloride. So zeolite recombine with sodium and they can form the previous one like zeolite Na2Z. For the reaction of that recombination of zeolite is metal combined with the zeolite, treating with sodium chloride solution, and now this is replaced this metal and they form here MCl2, and the zeolite is combined with the sodium and they form Na2Z zeolite. So hydrated sodium aluminosilicate is obtained by treating this metal zeolite with sodium chloride solution. So these two methods we used here to remove the permanent hardness of water. Hardness of water, what is hard water, what is soft water, then the types of hardness of water, permanent hard water and temporary hard water.